next set of functions that we want to take a look at are exponential and logarithm functions. The most common exponential and logarithm functions in the calculus course are the natural exponential function a is to x and the natural logarithm function ln of x. We will take a more general approach, however, and look at the general exponential and logarithm functions. So we'll start off by looking at exponential function. F of x is equal to a to the power of x. So that is exactly the opposite from what we've got with this function. So we're going to have to start with the definition of the derivative. So we have f prime of x is equal to limit h to 0, f times x plus h minus f times x over h. Then limit of h to 0 is a to the power of x plus h minus a to the x over h. And limit of h to 0, a to the power of x and a to the power of h minus a to the power of x over h. And limit of h to 0 is a to the x times a to the h minus 1 over h. Now, let's notice that the limit we've got above is exactly the definition of the derivative of f of x is equal to a to the x at x is equal to 0. So, like for example, f prime is equal to 0, therefore the derivative becomes f prime of x is equal to a to the x limit of h to 0 a to the power of h minus 1 over h. So we are kind of stuck. We need to know the derivative in order to get the derivative. So therefore the derivative becomes f prime of x is equal to f prime of 0 a to the power of x. There is one value of a that we can deal with at this point. Back in the exponential function section of the review chapter, we started the e is equal to 2.71828 and so on. So what we didn't do, however, is actually define where e comes from. There are in fact a variety of ways to define e. Here are 3 of them. So first, e is equal to limit of n to infinity times 1 plus 1 over n to the power of n. Second is e is the unique positive number for which limit of h to 0. So e is to h minus 1 over h is equal to 1. And number 3, e is equal to n is equal to 0 to infinity of 1 over n. So that's all for this video.